So in this lesson, we're going to talk about factors that are sums. We're also going to talk about pyramids and cones. We'll probably do that whenever I get back to class on Thursday. So factors or sums are very simple. Basically, going to take a little bit of what we did in lesson 69 and a little bit of what we did the last lesson and just kind of put them a little bit together here. So we look here, we have an a plus b times x squared minus a plus b times x minus 6 times a plus b. And as you can see, each one of these terms here have an a plus b in common. So we'll just go ahead and factor out that a plus b. So we're going to get a plus b here. Now, what we have left over is an x squared minus x minus 6. So we'll go ahead and put x squared minus x minus 6 in here. And just like we did yesterday, we're going to go ahead and factor out this x squared minus x minus 6. So a plus b, parentheses, parentheses. Again, we'll go ahead and put our x's in. We try to figure out what our factors of 6 are. So we have 6 and 1, 3 and 2. So 3 and 2 is going to come out to at least a 1. So we're going to put a 3 here and a 2 here. We'll give our largest number this sign, which would be a minus, makes this a plus. So our final answer is going to be a plus b times x minus 3 times x plus 2. So let's go ahead and look at another example here. We have x plus y times x squared plus 9x times x plus y plus 20 times x plus y. So again, we see that we can factor out an x plus y out of all of this. So we'll go ahead and put in x plus y. And what's left over, we have x squared plus 9x plus 20. So pretty simple so far. Now again, we're just going to go ahead and factor out our x squared plus 9x plus 20. So we get x squared, or x plus y, put in our parentheses, go ahead and put our x's in. We look at our factors of 20, 21, 2 and 10, 5 and 4. 5 and 4, when we add them together, would give us 9. So give us a 5 and a 4. We look at our signs, we both have positives. So we'll go ahead and just put positives in there. So now we have our final answer as x plus y times x plus 5 times x plus 4. So we'll take a look at one more example. When I saw this problem, I knew exactly what you guys were going to say. Oh, he's throwing, we didn't see one of these in the example, or we didn't see a problem like this, and so now we don't know what to do. And so we're going to look at this problem here. We have m times x minus 1, x squared, plus 7mx times x minus 1, plus 10m times x minus 1. Now once again, we can see that each one of these has an x minus 1 taken out. So we can go ahead and put our x minus 1. Now, if we look though, we have an m outside of this one, an x squared, a 7mx, and then a 10m. So you're going, oh, what are we going to do? How are we going to figure this one out? Well, if you see here, we can factor out an m here, we can factor out an m here, and we can also factor out an m here. So we'll go ahead and just put an m on the outside of here. And so our factor, what we actually were able to factor out of everything is m times x minus 1. And so when we do that, we are left with an x squared plus, when we factor out that m, it leaves us with 7x. Plus, we factor out this m, it leaves us with a 10. So, now that we've done that, we'll just go ahead and we'll factor out our x squared plus 7x plus 10. So we have m x minus 1. We look at here, we're going to go ahead and put our x's in. We actually see that we can go ahead and just put in both positives here. Now, what are our factors of 10? 1 and 10, 2 and 5. 2 and 5 is probably going to be our best solution here. So we can put 5 and 2 here. It doesn't make a difference whether you put a 2 here or a 5 here. So our final answer is going to come out to m times x minus 1 times x plus 5 times x plus 2.